Welcome. Please be seated. My name is Mehran Meswai, and I'm the interim chair of the department. On behalf of our faculty, staff, and the entire AA community, congratulations to the class of 2026. You are graduating at an extraordinary moment in aerospace. This past April, NASA Artemis II carried 4 astronauts, farther from Earth than any humans in history, breaking the deep space distance record set by Apollo 13 in 1970. One of the people who made that possible is our own Howard Hugh, NASA Orion program manager and a proud AA alumnus. He sat in the same classrooms, studied with the few professors that you know, and came back last week to tell us what it felt like to pull it all off. And Artemis is just the beginning. Commercial companies have now soft landed on the moon. We are on the verge of assembling large structures in orbit. Satellites can now be serviced and repaired in space rather than abandoned. The infrastructure for a sustained human presence beyond Earth is being built piece by piece, mission by mission. And it is being built by people who studied exactly what you have studied. Now it's your turn to build it further. And that's just space. Electric air taxis are closing in on certification. NASA experimental aircraft is taking aim at supersonic travel over land. Commercial airlines are deploying drag-reducing surface technologies that are cutting fuel consumption at scale. Quieter skies, cleaner skies, smarter skies. And while all that was happening out there, things were happening right here. Our students designed and built a shoebox-sized satellite, now orbiting Earth, after being selected by NASA. Design, Build, Fly came back from humbling 51st place, finished last year, to take 2nd place this year at the International AIAA competition. Two of our faculty, Professor Karen Lung and Ed Hapter, received a prestigious NASA Career Award in the same year. This is not a common thing. This department is doing serious work, and you have been a part of it. You studied in the middle of all this. You learned the math, the physics, and the systems thinking that underlie every one of these milestones, and now you're ready to go add to them. The problems your professors put in front of you are the same problems that industry is racing to solve right now. Our 2026 distinguished alumni can speak to that. Leila Elias graduated from this department in 1998. Went on to MIT and JPL and has built a career spanning space telescopes, rocket engines, and commercial aircraft, most recently as Vice President of Future Product Studies at Boeing. We'll hear from her shortly. The future of flight, whether that's 5 miles above the Earth or 5 million miles beyond it, it is in your hands. You will show the world what Huskies can do. I love that you're applauding. I really appreciate it. Thank you. Right timing. Before we hear from our speakers, let's celebrate some exceptional work from this year's graduating class. As you may know, the seniors worked very hard on their capstone projects. Capstone is our team-based design program to develop solutions for industry, our student organizations, or in-house research led by our faculty. Some of you might have watched our Capstone Film Fest, either in person or on YouTube. This past week, they presented their final design acceptance reviews, exploring the technical solutions of their projects. We would now like to recognize excellence in our Capstone program, starting with the Film Festival. For these team awards, please stand up if your team is called. You guys are ready? Okay, the People's Choice Award for the Capstone Film Fest is Sea Glider Team. Team, please stand up. This team built a digital twin of an underwater drone the UW uses for our ocean research that is deployed for months at a time. These drones can sustain damage like lost wing or rudder that puts the mission at risk. Their digital twin system helps operators spot damage early and bring it home safely. Congratulations, Sea Glider team. The Best in Show Award for the Capstone Film Fest is SARP 2 Stage Rocket. Team, please stand up. Most students-built rockets use a single motor, but this team is developing a two-stage rocket with a booster and a sustainer to reach altitudes that a single stage can't. This stage rocket will serve as the foundation for society's future high-altitude vehicles. Congratulations, SARP, to two-stage rocket team. One more time. Next, we have two technical capstone team awards. The winner for the innovation is Husky Satellite Lab. Please stand up to be recognized. The Husky Satellite Lab's ground-penetrating radar team set out to answer a question that isn't at any of our textbooks. Can a small satellite use radio waves to find tunnels hidden beneath the moon's surface? It's a brand new problem with almost no existing research to lean on. This team built a working prototype and a test plan for the ground up, laying the foundation for the Husky Satellite Lab mission for years to come. Congratulations, Husky Satellite Lab ground-penetrating radar team. And the Capstone Award for Technical Excellence is, should I make that sound again or no? 3D Wings Stamps team. Team, please stand up. So this Stamps Wing team, Stamps stands for the stall modes with printed sensors in wing, tackled two projects at once, building a sensor to detect stall cells, zones where a wing loses lift, and using it to test an open hypothesis about how those zones move across swept wings. They logged more wind tunnel time than any other senior design teams combined, collecting over 2 million data points in the process. Their conclusion was well-earned, inconclusive, which is the sign that they took the science seriously enough not to oversimplify it. Congratulations, Stamps Wing team. We will now shift to our undergraduate Student Excellence Awards for research and service, and award them for those selected who are graduating here today. The Student Excellence Award for undergraduate level research goes to Owen Schitzman. Owen, where are you? Come and get your certificate. Is Owen not here? Oh. Let me tell you what Owen has done. Owen used ultrasound inspection to identify defect signatures in 3D printed composite panels and connect those defects to mechanical performance, which is on track towards publication. He has since expanded into computational research, simulating fracture behavior in thermoplastic composites at microscale. The combination of experimental depth and computational range at the undergraduate level is rare. So let's clap for Owen one more time. The Student Excellence Award for undergraduate teaching goes Kiera Morrissey. Kiera, come up for your certificate, if you're here.
Yep, that's good. That's good. Just give her this, I don't know.
I'm going. Or you can stand. Okay, stand. So Kiera served as a TA for AA312, Structural Vibrations, where she brought a command of the material and genuine investment in student learning. She guided students through the in-class activities and drew in students who were hesitant to participate. In fact, I was in the classroom, and she did approach me to see if I have any questions. Before each of the courses, three exams, she recorded review sessions and shared study checklists. She also contributed thoughtfully on pacing, exam difficulty, and course material throughout the term. Congratulations, Kiera. Okay. The next award, the Student Excellence Award for Undergraduate Service, goes to Catherine Ingram. Catherine, come up to stage, please, if you're here. All right, so, oh, she is coming. Hello. So Catherine has dedicated nearly 700 hours over 5 years to STEM outreach and education. She led the creation of the Lego robotics program at the Don Hodge Youth Center in Tulip, a 6-month effort that served more than 30 Native youth and families and has continued under Everett Community College since her involvement. She has also contributed to Discovery Days, Women in Aviation events, Boeing Boys and Girls Club programming, and Highline school district workshops, collectively reaching hundreds of K-12 students. There is more. She also serves as a mentor in the Michael P. Anderson program at Museum of Flight, where she worked directly with 40 middle schoolers from low-income and underrepresented backgrounds over 6 months, and presented her own story to 200 students. Catherine also has made sustained personal commitment to making aerospace more accessible. Thank you so much, Catherine. So how am I doing? Plus? Thank you. I'm a control system engineer. I need feedback from time to time. It's now time for our Distinguished Faculty Award. Our graduating students submit nominations for the impact of our faculty on their experience and the community and therefore commitment to high academic standards. This year, 2 faculty members received equal recognitions and will both be honored. This year's award goes to Professor Amir Hossein Tawai and Bhuvana Srivansan. Please. Amir's mentorship is defined by a combination of intellectual rigor and genuine investment in his students as people. Rather than prescribing solutions, he pushes students to develop their own thinking, taking even preliminary ideas seriously and work through them with care. That approach builds research confidence alongside technical depth. Congratulations, Amir. Bhuvana brings exceptional range to her role as an educator and researcher. But what distinguishes her most is how she supports her students as whole people. She's attentive to the individual circumstances each student brings to their PhD, creating an environment where steady progress matters more than the pace of the milestones. Her students consistently describe feeling supported well beyond the technical demands of their research. That combination of intellectual depth and genuine care is what makes her lab a place where people can do their best work. Congratulations, Bhuvana. All right. So you're going to get a break from me in a second. But hang on. Okay. So now let's hear from 2 of our outstanding graduates, Hugh Suratgar and Eddie Tink. Hugh, please join us at this stage. Of course.
You want to do that real quick? All right. Everybody in the crowd real quick. Excellent. Awesome. Thank you so much.
I'm going to read something for you. So I proudly introduce our undergraduate speaker, Hugh Suratgar. Our undergraduate student speaker kept himself very busy at UW. He worked as a researcher in the quantitative flow visualization and RAM accelerator laboratories, led the Husky Flying Club, and made time to connect young students with the field at events like Engineering Discovery Days. This fall, he heads for CU Boulder for his MS, Masters of Science in Aerospace Engineering, with his eye on a career in flight testing. Please welcome Hugh Suratgar.
Thank you. Good evening. To the Aero and Astro class of 2026, I'm truly thrilled to say these 3 words to all of you today. We made it. Through hours of hard work, diligent preparation, and finally learning what our system requirements were, we can all be here today to celebrate this incredible achievement. Before I go any further, I would be remiss if I didn't first thank everyone in the department for their part in helping us achieve our goals. Thank you to our faculty, administrative, shop, and custodial staff for their tireless efforts in pursuit of our education. Without you, this place would not be the amazing institution that it is. I would also like to extend a personal thanks to Doctors DeBeery, Morganson, and Nolan for their mentorship and support provided towards both my club and research work here at the university. Your efforts shaped me into a more confident, well-rounded engineer and individual, and I will take the lessons I've learned from each of you to heart as I start my professional journey. Finally, to my friends and family, here in the audience today, throughout the United States and abroad, thank you. Your unwavering patience and encouragement were the foundation of everything I achieved here, and I share this milestone with you. As most of you may know, I'm not originally from here, but rather a transplant from elsewhere in the United States. I was born and raised in Northern Virginia, a stone's throw away from Washington, D.C., and spent my formative years, diplomatically, being dragged around the city in an attempt to soak up the knowledge offered by the world-class museums in the area. While I may not have appreciated it at the time, sorry, Mom, those early weekend excursions eventually sparked a curiosity in me, which was nurtured by my family. They emphasized education from an early age, with my maternal grandmother always telling me that it was the one thing that nobody could take from you, and I was encouraged to explore my options and find my true passions. After what I imagine were several frustrating years for my parents, I finally got the gist of their ethos, perused my options, and developed my initial interest in air and spacecraft, ultimately leading me down the path of aerospace engineering. I can't say I was the most naturally gifted student at times, but I applied myself in my studies and extracurriculars and put my best foot forward where possible, culminating in the opportunity for me to attend this great university. While my time here was defined by complex homework assignments, technical lectures, unintuitive lab equipment, and more wind tunnel tests than I'd really like to admit, it's not the hardware that I'll remember most, but rather the relationships I've made in this department that will stick with me for the rest of my life. This cohort of unique, wonderful, and talented students became its own family through our shared experiences, and our bond as engineering students prompted meaningful friendships that will stand the test of time. We supported each other when times were tough, celebrated our collective wins, and enjoyed both the ups and downs this degree had to offer. These relationships we made here over these past few years were not only valuable, but in my view, they are the most important assets that we can carry forward. Because in a world that's changing faster than ever, human connection isn't just a comfort. It's what grounds us in empathy, honesty, and integrity, allowing us to be our best selves. In fact, when considering the most important qualities one should have as a professional, it's precisely these tenets that spring to mind. As newly minted aerospace engineers, we possess the unique expertise to change the world through air and space. And by holding fast to these principles, we commit to using those skills for the benefit of all. Despite continual advances in technology, fast design turnarounds, and ever more complex technical challenges, the human element of engineering has remained constant. Throughout our history, we have continuously designed, iterated, and built off of one shared feature: each other. Whether that be through our desire to explore the unknown, defend ourselves, or to connect the world, the ideas driving innovation all stem from the core principle of human impact. I believe that we should embrace this not as a constraint, but as our ultimate launchpad, ensuring that as we look toward the sky and stars, our innovations remain firmly anchored on uplifting life here on Earth. When looking out at our class, there is no group of people I trust more to build that future than those in front of me today. I have seen the capabilities of each and every one of you with my own eyes, and I can't put into words just how much you have all amazed and inspired me during our time together. The road ahead will be long, and each of you will be challenged in ways not yet understood. But I have faith in our ability to persevere despite these obstacles. As Dr. Vijay once said, we chose this life. So let's get out there and do some amazing things. Thank you.
Thank you, Hugh. Wonderful. I feel so energized to go back to work. It's now my pleasure to introduce the graduate student speaker, Eddie Thing. I'm going to shake your hand in a second. Our doctoral student speaker came to the UW in 2018 and has spent the years since working on one of the field's most demanding problems, the aerodynamics and structural control of commercial supersonic aircraft. A researcher in our active aeroelastic structures lab and this year's Boeing Tesla Fellow, his work has been funded by Boeing, the FAA, NASA, and has involved collaborations spanning 4 universities on 2 continents. He's also been a consistent presence in the building community here, organizing the Control X seminars that gives graduate students space to work through ideas together. Please welcome editing.
Good afternoon, faculties, families, friends, and the class of 2026. Let's be honest about how we all ended up here today. When we were kids, many of us have 2 dreams: to become a pilot or an astronaut, or even both. But somewhere along the lines, things went horribly wrong, and we all become engineers. I could give you a big motivational speech today, but there are already too many perfect examples out there. If you want world-class motivational speech, you can look up Steve Jobs or Admiral McRavens. I cannot compete with them. And I definitely learned my lessons through the last few weeks about the Graduate Speaks Online. So I'm gonna spare you from the AI lectures. Instead, I want to talk about one reality that every single graduate in this room shares. We all become expert in failure. In our classes and labs, we learn how to build complex systems like airplanes and rockets. But at some point, things always fail. When the components of a system fails, we don't just simply throw them out the windows. We need to figure out exactly when it fell, why it fell, and how it fell, so we can build it better next time. And that's exactly what we did. We spent years racing against the deadlines while our results refused to converge. We all have been staring at the crashing simulations the night before the submissions, wondering why it went wrong. For the graduate students, failure comes especially with the heavy imposter syndromes. We spend years looking around, convinced that everyone knows what they're doing, while we're the only one making no progress behind closed doors. But the true values of our time here wasn't avoiding those moments. It was learning what to do after them. Life will throw failures at us. But just like broken piece of engineering, failure in life is just a bad converging point. It tells us exactly what we need to do so we can show up the next day and get closer to our dreams. And we didn't do it alone. AI might change how we work, but it cannot replace human connections. The next generation might have the best AI tools or tutors, but they will miss out on the late night grindings in the computer labs, with friends arguing with homework, sugarcoat pizza, and bonded being completely lost. Excuse me. We survive because we have friends who refuse to let us crash along. So cherish those people who stood by you at your lowest moments. Those are your true friends, not just the one who asked you out the night before midterms or finals. And to the faculties, staff, families, friends who supported us here, thank you. And now, congratulations to each of you. To the undergraduates, this is your first important milestone as an engineer. And to the master's students, you have proven that you can do completely independent work. And to my fellow PhD graduates, you now have the ultimate potential to become a supervillains. Because every villain in the movies have a PhD, so use that power wisely. But before I finish, I want to play a little game so-called Never Have I Ever with the graduates. Use your 3 fingers and then 3 questions, lower it if you haven't done this. Never have I ever failed in a class. Probably hide it from your families and advisor. Never have I ever failed a quarter. Never have I ever been dismissed by a university. Not here. I have done all 3. I have failed a couple of classes. a couple quarters, and been dispensed by university. I tell you this because success does not only belong to the one who with perfect records, but also to the ones who refuse to let their lowest moment define them. I'm pretty sure I wasn't chosen as your graduate speaker because of my perfect record. If I can stand on this stage today, absolutely every single one of you can handle what's coming next. The hardest part is over. Remember, sky was never the limit, it was just the beginning. Congratulations, class of 2026.
All right, thank you so much, Eddie. Wonderful. How can I follow up on, on these two great speakers? But I know a person that might be able to do. So we now turn to honor our 2026 Distinguished Alumni Award winner and keynote speaker, Leila Elias. As I mentioned, our 2020 graduates, Leila earned her undergrad degree from our department in 1998. And the trajectory since then has been remarkable. MIT for graduate school, JPL for work on dynamics and control for large space telescopes, then Blue Origin for onboard system level experience across the space vehicle program, and eventually Boeing, where she has developed an active vibration control system that flew on 737 Echo demonstrator. When the system switched on during his first flight test, she felt the cabin quiet down before the data plus confirmed it. She has built her career around this kind of engineering, rigorous, collaborative, and grounded. She is now Vice President of Future Project Studies at Boeing, focused on the next 20 years of aerospace, electrification, advanced materials, commercial space, and building AI into engineering practice from the start. Please join me in welcoming Leila Elias to the podium. Leila, I'm honored to give you I'm honored to give you the Distinguished Alumni Award for 2026, and I have my
Good evening. Chair Misbahi, faculty and staff, families and friends, and most importantly, graduates of the University of Washington, Department of Aeronautics and Astronautics, class of 2026. It's an incredible honor to be with you here today. 28 years ago, I was sitting exactly where you are, full of equal parts excitement and relief that I never had to take another aerodynamics exam. Sorry, Professor Bridenthal. I remember that feeling well. Hold on to it tonight. Being back on campus feels like a homecoming. Walking through Guggenheim Hall earlier immediately transported me back to grueling junior lab reports, wind tunnel data analysis, and stress strain curves. Some things about this place never change, and I know each one of you has your own version of those memories. The late nights, the breakthroughs, the moments of doubt, followed by hard-won understanding. Those experiences shaped you. You have learned and grown in ways far beyond what any college transcript can capture. And now you stand at the threshold of what comes next, carrying with you an education that is far more powerful than you yet appreciate. So here's something no one tells you on your graduation day. The education you just received is better than you think it is. Right now, it probably feels like a blur of Navier-Stokes equations and Bode plots and capstone presentations that may have had you questioning your life choices at 2 a.m. But what this department actually gave you is something deeper than technical knowledge. It gave you a way of thinking It gave you a way of breaking impossibly complex problems into pieces, a way of navigating ambiguity, and perhaps most importantly, an enduring belief that if something can be understood, it can be improved. I can tell you from experience that this foundation is strong. When I arrived at MIT for graduate school, I realized that UW had prepared me not just to learn, but to innovate and to lead. The rigor of this department is real. Your foundation is solid. You are more ready than you may feel right now. My career has taken me from NASA's Jet Propulsion Laboratory to Blue Origin to Boeing. I want to share a few moments from that journey because each one taught me something I wish someone had told me on a night like tonight. At JPL, I worked on dynamics and controls for precision space telescopes, making sure a telescope that's floating hundreds of millions of miles from the nearest repair shop could point with extraordinary accuracy. What I learned there was that in aerospace, the margin between success and failure is razor thin, and the cost of arrogance can be catastrophic. What JPL taught me is that humility is not a weakness in engineering. It's an essential attribute. I learned to check my numbers twice, and then to ask someone else to check them for me as well. I learned that the smartest person in the room is usually the one who's asking the most questions, not giving the most answers. At Blue Origin, I joined a small team trying to fundamentally change how humanity accesses space. We were working to make reusable rockets real at a time when most people thought that was science fiction. On the heels of an early prototype rocket failure, we were set out to update the design and try a different approach. What I learned there was the power of audacity paired with discipline. You can dream enormous dreams, reusable rockets, routine space access, but you still have to do the math. You still have to test the hardware. You still have to be honest when something doesn't work. And when you encounter a failure, you realize it might actually be a success if you can learn from it. Then you pick yourself up, you make adjustments, and you try again until you achieve the goal. The vision is what gets you out of bed in the morning. The engineering is what gets you home safely at night. You've been practicing that balance of ambition and rigor throughout your education. Now you get to apply it to real-world challenges. At Boeing, my career took turns I could never have predicted. I moved into propulsion engineering and then into executive leadership, leading the development of new airplane models and now future airplane development studies. The point is not the specific path. The point is that careers in aerospace are not straight lines. They are complex trajectories influenced by gravity, thrust, drag, and the occasional unexpected crosswind. The key is to keep your heading aligned with your passions and to trust that the skills you built here will serve you in ways you cannot yet imagine. So with a couple decades of hindsight and a fair number of hard-won mistakes, let me offer you a few pieces of advice. First, chase the hardest problems. It may be tempting, especially early in your career, to gravitate toward work that feels safe and achievable. Resist that temptation. The hardest problems are where the most meaningful work lives. Space telescopes that see to the edge of the universe, rockets that land themselves, airplanes that are safer and more fuel efficient than anything that has flown before. These problems are hard precisely because they matter. And with the education you have from this department, you are equipped to tackle them. Don't shrink from this complexity. It's exactly where your talent is needed. Second, no one builds anything great alone. Every spacecraft, rocket, and airplane ever built was the product of collaboration across disciplines, perspectives, and expertise. The most important skill you will develop in your career is not technical. It is collaborative. The ability to listen to someone from a completely different background, understand their constraints, respect their expertise, and find the solution together that no one of you could have found alone. I've seen brilliant engineers fail because they could not collaborate, and I've seen good engineers become extraordinary because they could bring a team together. Be the person who makes everyone around you better. That is leadership, whether or not it comes with a title. Third, give back. Those of us who have benefited from extraordinary education and opportunity have a responsibility to pay it forward. Whether that's mentoring a younger engineer, serving your community, supporting this university, or simply being the person who makes space for someone else at the table, give back. Your career will be richer for it. Your life will be richer for it. And the industry needs people who care deeply about the community around them, and not just the next technical achievement. Also take a moment to thank your family, friends, professors, and advisors who supported you on this journey. Tonight, they share in your success. To my family who is here tonight, and to this department, you have my deepest gratitude. Lastly, embrace what's coming. You are graduating into a moment of extraordinary change. Artificial intelligence, advanced manufacturing, autonomous systems, commercial space. The pace of transformation in aerospace is unlike anything I've seen in my career. Some people may find that daunting. I hope you will find it energizing. These tools are not a threat to your expertise, they're an amplifier to it. Learn them, shape them, bend them to your purpose. Use them to solve problems that previous generations could not. You are entering an industry that's being reinvented in real time, and you get to help shape what's coming next. Today, you leave this campus with a world-class education, a degree to be incredibly proud of, and enormous potential. Here's what I'll leave you with. Step boldly. Not recklessly. You are engineers after all, and we don't do reckless. But boldly. Take the job that stretches you. Raise your hand for the project no one else wants. Change disciplines. Move across the country. Start something new. Trust that the foundation you built here is strong enough to support whatever you choose to build on top of it. You are aeronautics and astronautics engineers from the University of Washington. You are trained to reach for the sky and then keep going. The world needs exactly what you have to offer. Congratulations, class of 2026. It's T-0. Go launch something extraordinary.
Thank you, Leila. That was exactly the inspiration our graduates needed to hear as they begin their careers. Now it's time to honor the students of the class of 2026. We will call each graduate up for this diploma holder. We have a little ANA certificate in the holder, but you can swap it out for your UW diploma when you receive it. So we're going to start with PhD hooding. First, we turn to one of our most cherished traditions, honoring our doctoral graduates. We begin with those students here today who have earned the Doctor of Philosophy with a few words from their faculty advisors and the ceremonial hooding. This year, we have 10 students receiving their doctorates. 5 of them have worked with under Professor Behçet Açıkmeçe, who will be leaving us for UC Berkeley. You can show your emotions if you want. We thank him for all his years here and for the excellent research he and his students have sent into the world. We will start with those 5 students. Are you guys ready? All right, Govind Chari. Govind, please come up. So I'm going to read. Govind PhD dissertation is on structure exploiting and accelerated methods for convex optimization with Professor Açıkmeçe. After graduation, Govind will work for Citadel as a quant researcher.
What can I say about Govend? Govend is, first of all, he's only 25. 24 and a half, maybe. When I was his age, I was nowhere to be near him, you know. So Govend did an amazing job during his PhD. His ability to acquire complex ideas, turn them into workable projects, and executing them is amazing. He was very independent, self-taught. Many areas he picked up by himself with little supervision, and he completed his PhD and master's, in a way of speaking, in less than 4 years. This is an amazing achievement. I think he will do amazingly in his next steps. The only advice I gave him was to be slow. Slow down. You are making us all look really bad. But having said that, seriously, he should slow down and enjoy his life, because I think there's no way that he will not succeed. So with that, I congratulate Govend.
All right. Abby, come out. Abby, oh. Abby, come out. So Abby recently started working as a research, oh, okay, so let me do it properly. Abhinav Girish Kamat. The title of the dissertation is Real-Time Trajectory Optimization for High-Performance Guidance and Control, with Professor Ashik. Abby recently started working as a research scientist with flight controls team at Amazon Prime Air. Abby would like to thank his PhD advisor, Dr. Ashik, his mentors, friends, family who are here with us today. That.
I really want to identify something different for each student. And Abby, it's hard because he does everything. But there is one thing that I can say that he's probably one of the best I have seen. You give Abby an application he likes, he will put pieces apart, analyze each piece very, very carefully, be very rigorous, and put them back together very successfully. And he did it in multiple projects that he worked on. He actually won one of the best paper awards in AIAA SciTech. And this is not an easy award to win. We didn't even know that this award would be given to us. And Abby, what he contributed to that project literally enabled a new technology NASA is testing as we speak. And as a PhD student, it's really, really hard to do. And he really saved the day multiple times in that project. And he also worked on other projects where he excelled as well. Again, his rigor, his love of applications, aerospace, particularly space applications, is what distinguishes him. And he's a very, very hardworking individual. I'm sure he will be successful. He's one of those students I don't think he will ever fail. Thank you, Abby, for all the good work you did. Congratulations. Or maybe I should be here.
Next is Taewon Kim. Taewon, please come. So Taiwan's dissertation is robust predictive control for uncertain nonlinear systems via funnel synthesis. Taiwan is grateful for the support of his wife and for his advisor's guidance throughout his PhD. He is proud of his research accomplishments and of raising his son with his wife while earning his doctorate.
I'm running out of words, but I have more for you, Taiwan. Taiwan joined my group several years back. He came from Korea. I didn't feel how he graduated because he's so good in what he does. Let me give you an instance of our conversations. I typically am very good in derailing PhD students and the conversations. With Taiwan, I never accomplished that goal. The reason is when he comes, he's so clear-minded, he knows what he's talking about, and he's an extremely rigorous guy. So he comes, he has a meeting for an hour, it ends in half an hour, and I have no comeback. This is an unusual thing to do. He has written many, many papers during his PhD. He was very successful. Whatever he does it so smoothly. I think Starling is very lucky to have you, Taiwan. And his maturity is also something else. Raising a family while doing his PhD and transitioning to a life in a different country, these are not easy tasks. Taiwan did them all very smoothly and successfully. Congratulations.
All right, we have two more from batches. Sky McCohen, Mike Yuan. Congratulations. So Sky's dissertation topic title was Trajectory Optimization Methods for Hypersonic Flight and Aerospace Vehicles. Sky recently completed her PhD focusing on trajectory optimization for entry, descent, and landing, including collaborations work with NASA. She will be joining SpaceX in LA to work on guidance, navigation, and control for Starship.
Sky is another interesting student. All of them have their stories. Sky came to my group, and maybe in terms of preparation, she was the most unusual one. She had to recover a lot of material. That's typically what my students take as undergrads or grad students. But what distinguishes Sky is her courage. I think she took on a task that was initially difficult. She worked really hard. The distance she put in those years was amazing to see. That work, that hard work, that grit led to many successful projects. One of her papers won the best paper award in SciTech for the best atmospheric flight paper last year, I think it was. And that was really the pinnacle of her PhD. And the other quality Sky has is her collaborativeness and her energy. I sent new students to Sky because after they talk to her, they decide to work with me. So, and also she goes around and talks about what we do, and everybody else wants to work with us. So that was amazing. For example, she established a lot of collaborations with NASA, not me, her. And they are going really well as we speak, and I hope they will conclude really successfully. That all the indications are that way. And she will go to SpaceX. She already established collaborations with SpaceX. I mean, that's amazing. Again, thanks to her very collaborative nature, very supportive nature. And I am sure those qualities, her courage, grit, and collaborativeness, will serve her very well in SpaceX. Where will she need it, actually, right, Sky? It's a tough job. Congratulations, Scott.
All right, Samet, you're ready, right? All right, Samet Uzun, come on. So Samet Uzun dissertation is modeling and high-performance algorithm for trajectory optimization. Samet focused on his PhD work on modeling and high-performance optimization algorithm for autonomous systems. He's excited to join Zook's trajectory generation team to help develop autonomous vehicle technology. Congratulations, Zook. Samet.
I met Samet before his PhD, before he started his PhD, and he was working on a completely different area that I also had common interest. He wrote one of what I thought was the most creative papers in that domain. That's how we get to know each other, so I hired him. But Samet is also highly nonlinear, almost like an artist. You have to give his room. Sometimes he acts like he's not doing anything. You are like, what's going on with this guy? But in the last 2 years, the creativity and the productivity he demonstrated during his PhD was amazing to see. Again, this is a little bit about his nonlinear nature. But having said that, his work is one of the top-notch quality. He penetrated very difficult, challenging ideas in depth, and he demonstrated a lot of productivity, which is ultimately the real bar. And all these things together, I think he really did an amazing job. And I think in his company, his qualities as a deep thinker, creative thinker, I think he will do amazing things in whatever field he works on. And he has a canny ability to internalize and express ideas in his own way, which is actually quite nice to see. He's a very refreshing student to work with. Thank you, Samet, and congratulations. Yeah, I'm also a graduate.
Thank you, Bechet. So now, next is Nicholas Andrews. Please come up to the podium, please. Nicholas Brian Andrews, PhD dissertation is on observability of bio-inspired multi-link robots and camera-guided systems with Professor Christy Morgensen as the advisor. Nick would like to thank his parents, Corel and David, his brother, Dan, his advisor, Christy, and the rest of his family and friends for their unwavering support. Congratulations.
All right, well, it has been my pleasure to be Nick's advisor for the last several years. He actually started in the pandemic, so that was the first of his adventures. I don't think we met in person ever for like a year. And then he immediately dived into anything that was an adventure. So I'd say that's kind of the defining feature of Nick. So he spent 10 days at sea with the School of Oceanography on a mission, out doing ocean observatory work. And then came back, worked on things that were space applications. So the work he's doing, sort of vision-enabled pose estimation. So that's so you can figure out where something is so you don't run into it unintentionally and actually dock with it properly. For space vehicles, so there was some work with Blue Origin. And then he was a Fulbright scholar in Norway for, I think, 8 months total. Worked on underwater vehicles there and then came back and transitioned all that into bio-inspired underwater vehicles. So It has been a pleasure. I look forward to seeing what you do next, and congratulations.
All right, Aria Ter, please come up. Ari's dissertation is on development of generalizable understanding of cross-flow turbine design, intercycle velocity control, and parametric changes in rotor geometry. Advisor Owen Williams. Ari would like to thank their family, friends, colleagues, and various oversized rocks for supporting their sanity throughout their PhD. Ari, congratulations.
So Ari's advisor, Professor Owen Williams, can't be here today, so he asked me to say a few words. So I'm one of Ari's committee members. So Ari's passion for the environment, travel, and adventure, and clever engineering solutions were immediately apparent when he joined us here at the University of Washington. His work advancing our understanding of cross-flow turbines for marine renewable energy applications has been exemplary. Ari is one of those rare people who can spend hours exploring a difficult question, not simply looking for an answer, but seeking to understand the deeper implications for engineering design, operation, and deployment. I am excited for all that Ari has achieved and to watch his next chapter unfold. On a personal level, Ari has been an absolute pleasure to work with. He is insightful, kind, patient, reliable, and remarkably resourceful. He's generous with his time, quick to help others, and unfailingly thoughtful in his approach to both research and collaboration. As he moves to the next stage of his career, I am excited to see the impact he will undoubtedly have. At the same time, I am genuinely sad to lose one of my favorite collaborators. I will miss having someone whose judgment I trust, whose questions consistently improve my own thinking, and whose ideas have so often shaped the direction of our work. Perhaps this is the greatest compliment I can offer today. While I am proud of everything Ari has accomplished as a student, I am even more proud to now call him a colleague.
Okay, next, Peter Toro, please come up. So Peter's PhD dissertation is on advanced techniques for hull thruster research and development with Professor Justin Little. Peter is working at EOI Space as a senior propulsion engineer.
So I should start by admitting that when Peter asked to join my lab, I almost said no. And the reason that is because I started in 2018 and I already committed myself to 3 students at the time. And I didn't know if I could support a 4th. But then he took my lab course on electric propulsion. And during that, I was blown away by his technical capacity, his passion for engineering, his just creativity. And so I knew at that time that I had to find a way to make it work. And that turned out to be a great decision because Peter is a once-in-a-generation talent. He, both in terms of engineering, and as I later learned out, also in terms of downhill skiing. So if I may, I can highlight a few of his accomplishments over the years. So he designed a reconfigurable, very unique Hall effect thruster and built it with a shoestring budget that then later became part of his thesis, and also we used in my lab for other funded research. He also climbed to the top of Mount Rainier and skied down. He has built much of the components in my lab, multiple space simulation chambers that we use to support our research in electric propulsion. He then climbed to the top of Mount Baker, Mount Adams, and St. Helens and skied down. He has been a fantastic collaborator for other PhD students in my lab. Oftentimes he comes to the rescue when an experiment's not working. This is both for other PhD students and also industry partners. He took a helicopter to the top of a mountain in Alaska, jumped out of the helicopter, and then skied down that mountain. And then finally, in terms of his thesis research, he demonstrated that it's possible to apply machine learning methods to the optimization of electric thrusters and their understanding and ultimately deployment. For this, he was awarded 2 best papers 2 years in a row at the International Electric Propulsion Conference, and so his work is really quite outstanding. So that's all to say. I am very lucky to consider Peter among my first set of PhD students. Peter, it was a pleasure advising you, and I look forward to continuing working with you as both a friend and a colleague.
All right, next is Spencer Chrysler. Congratulations. So Spencer is my student, and I'm gonna be, first let me read, so you're gonna hear me twice, fine. Spencer, PhD dissertation is on controller synthesis to Riemannian optimization. Spencer is proud to have earned his PhD and would like to thank the AA department, the Rain Lab, and his mentors, Mehran, me. I have a hard time pronouncing my name, Shayar Aditya. He would like to thank his wife, Kaylee, and his family, and is excited to join the Amazon Leo as a GNC engineer. So it has been a real pleasure to be your PhD advisor, Spencer. It seemed like yesterday that you walked in the lab as an undergrad student, eager to get involved with research on autonomous systems. Your enthusiasm for research, your sharp mathematical mind, and how you were not afraid to ask questions and tackle difficult problems were impressive to me from the get-go. And what is even more refreshing is that you kept that eagerness, an eager mind, an inquisitive attitude to whatever you get involved with throughout your PhD. This was exactly the attitude that you needed to receive one of the highest recognitions for fundamental research for PhD students in control systems, the Best Student Paper Award at IEEE Conference on Decision and Control, and devising novel algorithms for distributed optimization on Lie groups, and making fundamental contributions to guidance control by creative use of Riemannian geometry and convex optimization. You know how I value your sharp mind and keen eyes for tackling fundamental problems, how you always work on improving yourself on all aspects of your life, and how dedicated you are to your friends and family, and of course, your awesome spouse, who throughout the years graciously joined our lab social gatherings whenever she could. I know you will be interacting for years to come, both as colleagues and friends. Congratulations, Dr. Spencer Chrysler. Left or right? All right. We're getting there. So let's see. All right, and of course, our distinguished graduate speaker. So Eddie Ting, please come up to the podium. So Eddie's PhD dissertation is on contribution to commercial supersonic aircraft, low-speed aerodynamic design, and aeroservoelasticity demonstration. And the advisors are Professor Eli Livni and yours truly, Mehran Mesbah. Eddie would like to thank his parents, sister, and girlfriend, Amber, for their constant support throughout his studies. Eli?
Hi, everybody. Usually with the years, students and family talk with gratitude about the experience and the good care that their professors took of them. I hope you got a taste today of the other perspective, which is how much we, the faculty, appreciate the brilliance, the innovation, and the hard work of our graduate students, without whom basically we cannot do any significant research. And so I can speak here for three of my colleagues who helped mentor Eddie. He was mentored by Professor Mesbahi here on the stage, Chet Nelson, who was not here, one of Boeing's and actually the world's most experienced configuration designer and a leader of supersonic airplane design, and Professor Reza Sultani, a very experienced experimental aerodynamicist. It was really a privilege and our good luck to have Eddie as a graduate student. Now think about some of the dreams of flight. Think about flying from here to the Far East or to Europe at half the time, and think about doing it comfortably. So the dream of supersonic flight, supersonic commercial flight, NASA invested a lot of money and a lot of time in shaping airplanes so that they would fly efficiently at supersonic speeds with a sonic boom that would be acceptable, but neglected almost completely the question of how these airplanes will handle at low speeds when they take off and land. And also, these airplanes, very slender, like arrows in the sky, flying very, very fast, are very flexible and very sensitive to excitations by gust. And all of you who've flown airplanes into storms on a rainy day and the airplane is shaking like crazy would appreciate how important it is to make the ride comfort good and to make sure that no dynamic stresses in the structure will be more than what's allowed. And so Eddie has contributed to work in all of these areas. He really led our work on the low speed characteristics of supersonic airplanes in our large wind tunnel. Thousands of cases that were analyzed and tested, meticulous work that will serve for years. Any designer of a supersonic airplane in the future will use the data that he helped create, and also working on the active control of what we call aeroelastic behavior, which is how flexible airplanes respond to excitations by atmospheric turbulence, and devised control laws and demonstrated them in our small wind tunnel, in our large wind tunnel, and in a wind tunnel of our colleagues in Italy, in Milano, where we test very large flexible models at the Politecnico di Milano. Really phenomenal work, meticulous work. We are very privileged. We have been very privileged to have him. With all his capabilities, he's a very humble person, and every time I try to tell him how great he is, he kind of dismisses me or shuts me up. But here, he has no choice but to listen to all this praise, which he deserves. So congratulations, and it's been really a privilege to have you as a student.
And one more picture. Congratulations to our 2026 PhDs. Since I have not been in too many photos, I want to invite you guys one more time as a group to take a picture as all the PhDs on center stage. So please. So before I invite Professor Eric Herlin to take the microphone to announce our graduates for the MS and also the BS degree programs, I want to take a minute and thank all the faculty members in this group. You kind of have heard from some of them about the work that they have done with their graduate students, but all of them do amazing work in their research. You can see where they graduated and when. Don't look me up, it's a long time ago. But these guys are just amazing. And I think you see the quality of their work reflected in the grad students. And they're also amazing teachers. So I wanted to thank the faculty for being here and supervising the students throughout your career. So thank you. All right. Professor Eric Herlin, please join me at the podium.
Hello, everyone. So students, we'd like you to stand one row at a time and in the aisle come up to the stage on my right. We'll wait to call names until everyone's lined up. Come up when your name is called, hand me your card, and walk across the stage to get your certificate from Professor Misbahi. Please pause for a photo on stage after receiving your certificate. We'll read a name and a statement for each student. You can applaud after the statement. We will start with the Master of Science. Start with an easy one, apparently. Grish Varthan Anusha Singaravilan. Grish is proud to have conducted research at the Multi-Scale Analysis of Materials and Structures Lab, specializing in advanced composite materials. He looks forward to applying his experience in structural design and simulation to innovate in the aerospace industry. Luke Goldberg. Luke would like to thank his wonderful girlfriend, parents, siblings, and friends for their endless support, even in his times of greatest uncertainty. Alexandra Guzman. Alexandra will continue her career with Boeing, leading advancements in composite materials and structural development. She extends her heartfelt thanks to her husband, children, and family for their unwavering support and encouragement throughout her journey to earning this degree. Gaurav Joshi. Gaurav is grateful to his family, mentors, and friends for their support and is excited to continue his journey as a PhD student in Aeronautics and Astronautics at Purdue University. Joseph Noth. Joseph is starting a job as a mechanical engineer at Blue Origin, a part of the Lunar Permanence Division. Joshua Kreitz. Joshua is proud of the work he did investigating aerodynamic performance with engine nacelle strakes. He will use what he has learned to advance his career forward into the field of aerodynamics. Lily Laplace. Lily is excited to continue with a PhD at UW in the Space Lab and return to NASA's Armstrong Flight Research Center as a Pathways Engineering trainee this fall. Kai Alden Laslet Vihil. Kai would like to thank his parents and grandparents for supporting him through his journey in higher education. Adrian Manhim Lee. Adrian is indebted and thankful for the team members at Design Build Fly UW and the G3MS Lab. Ray Chi Lee. Ray Chi would like to thank his parents and family for their love and support. Gordon Liao. Gordon is proud of their work in the Vortex Transport Lab and the Quantitative Flow Visualization Lab and is excited to work at Aeromech Incorporated this summer as an aerodynamics engineer. Avi Matol. Avi would like to thank his family and advisors for their patience in the face of suboptimality and for their support in helping him navigate through uncertainty. Connie Fung. This summer, Connie is excited to start flying again and working on her instrument rating. Anurag Rao. Anurag combined his background in mechanical design and aerospace structures to research bio-inspired gyro metamaterials for impact absorption application, and he looks forward to continuing his work in advanced engineering systems and product design after graduation. He would like to thank his professors, family, colleagues, and University of Washington for the guidance and support throughout his journey. Now I'm done. Parth Shroti. Parth would like to thank his family for their support through his educational journey and is excited to join Blue Origin as a guidance, navigation, and control engineer. Andrew Tackes. Andrew would like to thank his friends and family for their love and support. Kenneth Wiersma. Kenneth would like to thank Professor Livney and Chet Nelson for the opportunity to work on the Scalos project and the Kirsten Wind Tunnel for providing hands-on experience with aerodynamic testing. We will now recognize students receiving a Master of Aerospace Engineering. William Connor Baldwin. Connor would like to thank his family, his girlfriend, and Boeing for their investment in and support throughout this journey. He is proud to continue his work as a structural engineer and looks forward to applying his MAE with a focus in composites to the future of aerospace innovation. Marshall David Salazar Carter. Marshall is fascinated by control theory and aspires to one day apply what he learned in the MAE program to help design orbital space infrastructure systems. Kevin Castaneda. This diploma is a testament to God's grace and my family's endless sacrifices. Michael Cook. Michael is a mechanical engineer at Boeing and is looking forward to a continued career in aerospace and astronautics. He would like to thank his family, friends, and Boeing for the support. Nicholas Del Toro. Nicholas would like to thank his wife and family and will be continuing his career in engineering at Boeing. Iram Erkan. Iram is proud to complete her master's degree while working full-time as a flight controls engineer at Boeing. As an immigrant woman in STEM, she hopes to inspire other young immigrant women engineers to keep pursuing ambitious goals, even through difficult circumstances. Philip Fronchek. Philip is grateful for the encouragement and support of his family and friends, and for the Aero Astro faculty, whose genuine passion for teaching is abundantly clear. Jason Franklin. Jason would like to thank Melissa for all her support making his degree possible. Christopher Gaizka. Christopher would like to thank his family and friends for the continuous support throughout these years by keeping him sane. Abdikarim Abdullah Moalim Ibrahim. Abdikarim is proud to have contributed as a propulsion test and evaluation engineer to programs including Blue Origin's New Shepard and New Glenn engines, the 737 MAX recertification effort, and the GE9X engine for the Boeing 777X. He is grateful to his professors, mentors, classmates, and family for their unwavering support and looks forward to advancing the future of aerospace propulsion and guidance systems. Kevin Visoth Kadip. Throughout his journey to completing the MEE program, Kevin continued to maintain his full-time employment at the Boeing company in his capacity as a senior aircraft systems engineer, lead supporting the U.S. Navy P-8 Poseidon and U.S. Air Force E-7A aircraft programs. Kevin is especially thankful to his family, his wonderful wife Lily, and his two sons, Justin and Karaman, and all MEE academic advisors and faculty members for their support and made his study successful. Can we go over a limit next time? Alex Kerr. Alex would like to thank his friends, family, and mentors for their support and is excited to continue his career as a manufacturing engineer at Boeing. Chi Kim Lai. She worked hard to reach this moment, and she is proud of the journey that brought her here. Richard Lee. Richard would like to thank Boeing for financially supporting his ME degree and looks forward to pursuing his private pilot certification. Chris Michael Leichhardt. By grace and discipline, Chris has reached this milestone. His master's degree isn't just an achievement, it's a commitment to build, to serve, and to rise. Toan Liu. Toan would like to thank his family and friend that supported him during this master's program. Eder Martins. Eder would like to thank his wife and son for all the support. Mason Martuselli. Mason is proud to celebrate with his parents and thanks them for inspiring his passion for aerospace engineering with countless model airplanes and Lego sets throughout his childhood. Megan McMahon. Megan would like to thank her parents for always supporting her. She's excited to continue her career at Boeing Commercial Airplanes as an auto-flight control law engineer. Ty Meckling. Ty is a Navy pilot and flies the EA-18G Growler out of Whidbey Island, Washington. He'll be deploying overseas next year aboard the USS Eisenhower. Emilio Morales. Emilio would like to thank his wife and parents for their support and motivation to achieve this milestone. Huang Nguyen. Huang officially finished his MAE while working full-time as a structural analysis engineer at Boeing. He's incredibly grateful to his beloved wife for his constant support. He also sends a special thank you to his mom, dad, and his amazing sister for every moment they cheered him on. Up next, Huang is starting a second master's degree while continuing his climb towards a senior engineering position. Mini Anthony Nozinovich. Minya would like to thank his family for being the foundation behind his success, whose constant support, sacrifices, and belief in him made this achievement possible. Jack Pascoe. Jack would like to thank his family for their unending support and his mom for reminding him to pay tuition on time. Trun Tan Nam Pham. Tran sincerely thanks his wife, Trem, and his friends, Yi, Tuan, and Huang for their steadfast support and encouragement, which have been invaluable throughout his academic journey. Matt Pierucci. Matt would like to thank his girlfriend, Jocelyn, and his parents, Angelo and Kathy, for their encouragement and support. Nicola Rosso. Nicola owes so much of this moment to his parents, whose unwavering support and encouragement carried him through every challenge. He's excited to apply this degree towards the next chapter of his career at Boeing. Robert Kipchumga Ruto. Robert celebrates the completion of his graduate studies in aerospace engineering. He shares this milestone with his family and looks forward to contributing to the future of global aviation. Maxwell Anthony Schreiber. Maxwell would like to thank his parents, family, friends, and fellow graduate, Nicola Rosso, for their support. Alexander Twaits. Alec would like to thank his wife, Taylor, for keeping him sane and grounded throughout this journey. Alec is looking forward to continuing his career at Blue Origin, building a road to space. Soren Witter. Soren is excited to take what he learned to work. He also wants to thank his loved ones for their support and patience during his education. Adam Usury. Adam would like to thank his family for being a pillar of support and always being in his corner. Now we will recognize students receiving a Bachelor's of Science in Aeronautical and Astronautical Engineering. Dominic Acosta. Dominic would like to thank his incredible wife, Nicole. He would not have crossed the stage without your love, motivation, and endless support. Thomas Almquist. Thomas would like to thank his family and friends, especially his mom and dad, for their unwavering support throughout his time at the University of Washington. Bailey Anderson. Bailey would like to thank her mom, dad, brother, and grandma for being there and always showing their unconditional support. She is excited to be joining Boeing soon as an engineer on the aerodynamic performance team. Daniel Aribenio Langarica. Daniel would like to thank all his friends and family. I like that one. Matthew Elward. Matthew would like to thank his friends and family for supporting him throughout his time at university. Colin Blair. Colin would like to thank his parents for always being there for him. He appreciates all the hard work they put in to allow him to stand here today. Aidan Blumenhagen. Aidan would like to thank his family for all their support and excited to start his job at Janicki as a manufacturing engineer. Jason Bowman. Jason would like to thank his friends and family for all the support they've given him over the last 4 years. Oris Brikovich. Oris would like to thank his family and friends for all their support over the last 4 years. In addition, he is very grateful for the words of wisdom passed down to him by his professors, TAs, and graders, even when it was a bit painful or stressful at the time. Logan Carty. Logan is proud of the work he did on the Boeing capstone project and would like to thank his friends and family for all their support. Molly Chapman. Molly is starting a job at Relatively Space as a vehicle integration and test engineer. Ian Chong. Ian would like to thank Professor DeBeery for being a positive influence throughout his time as a student and is proud of both the work he did for the inertial navigation for a drone dropped airframe capstone and his time as a student at UW. William Crosby. William would like to thank faculty members, his family, and the handful of other individuals who freely gave their time to helping him earn this degree. Jordan Cummings. Jordan is proud of the work he did on the Sea Glider capstone and would like to thank Katrian and his family for all of her love and support. Nathan Dang. Nathan would like to thank his family who gave him the opportunity to stand here today as an educated engineer and his friends who helped him discover his passion. Benjamin Din. Benjamin would like to thank his family, friends, and mentors for all of their support. He is proud of his work on the integration and manufacturing teams in the Society for Advanced Rocket Propulsion. Alex Drystedt. Alex would like to thank his incredible family, friends, peers, and colleagues for their unyielding support over the past 4 years and for making his walk today possible. Chris Ellis. Chris would like to thank his wife Amanda and his children Violet and Olive for their unwavering support over the past 5 years. He could not have done this without their love, sacrifice, and belief in him. Ava Falk. Ava is starting a job at Boeing as a mechanical hydraulics engineer. She would like to thank her family for their love, support, and encouragement. Ryan Fan. Ryan would like to thank his parents for their tireless work and unimaginable sacrifice that allowed him to be here on the stage today. He hopes to continue making them proud. Alexandra Fenchenko. Alexandra is excited to continue her education at Stanford University next year. Jimmy Fowler. Jimmy is interning at SpaceX and Relativity Space this summer and fall, respectively, before starting as a PhD student at the University of Colorado Boulder, researching spacecraft guidance, navigation, and control. Dale Gradwell. Dale would like to thank his siblings and parents for their patience and guidance over the years. He is also grateful to his friends for pushing him to grow into a better engineer. Anthony Rodrigo Pablo Quinto. Anthony is excited to start his career in the aerospace industry in Southern California. Dylan Hoffman. Dylan would like to thank all of his loved ones for their continued support. Walker Alex Holmquist. Walker will be serving as a pilot in the United States Air Force. He would like to thank his friends and family for their support in achieving this dream. Henry Hong. Henry would like to thank his friends and family for supporting him for the next chapter of his life. Matt Howe. Matt wants to thank the DCS sim team for the late night training sessions and amazing memories, as well as the GPS denied capstone for the hard work on the most chaotic project he's been through at UW. Catherine Ingram. Catherine would like to thank her friends, family, and Space Grant for all their support. She would also like to give an honorable mention to Red Bull and Monster Energy for pushing her through achieving her degree. Holland Kantner. Holland would like to thank his grandma for adopting him. Grace Kenny. Grace is proud of the work they did on SARP. Emily Koo. Emily would like to thank her mom, dad, sister, brother, friends, classmates, and professors who supported her and believed her throughout her degree, and she is grateful for the opportunities that made this possible. Leticia Laura. Leticia is excited to continue to graduate to graduate school for quantum science and technology. Tyler Lawrence. Tyler would like to thank his family for all the support they have given throughout his academic journey. Alexander Sang-Hyuk Lee. Alexander would like to express their deepest gratitude to his family for their endless love and support throughout this journey. He would also like to extend a special thank you to Professors Carl Nolan, Bhuvan Srinivasan, and Yuri Shimlak for their guidance and mentorship in his research. Zachary Lewis. Zachary is starting a job at Boeing as a systems stress engineer. He would like to thank his family for their continued support throughout his time at UW. Jonathan Lee. John is relieved that he can finally sleep in peace for 3 months before coming back. He blames/thanks Professor Little for that one. Elise Leon. Elise is excited to be pursuing her PhD in nuclear science and engineering at MIT next year. Forrest Lynn. Forrest is starting as a 737 MAX liaison engineer at Boeing this fall. Jonah Lynn. Jonah would like to thank his beloved fiancée for being his inspiration and greatest supporter these past 4 years. He wouldn't have made it without her. Grace Lovell. Grace would like to thank her family and friends for their support during her undergraduate education. She is excited to be continuing her education next year at CU Boulder, pursuing an MS in aerospace engineering. Iker Martinez Lucero. Iker would like to thank his parents for being his biggest motivation and biggest supporters. This was all done for them. Okay. Jillian Robin McRae. Jillian would like to thank her family, boyfriend, and friends for always supporting and encouraging her. Miles Miller. Miles is proud of the work he did on his General Dynamics capstone project. Elliot Montoya. Elliot would like to thank his friends and family for the continued support. He is excited to continue his education in the MSAA program at the University of Washington next year. Kira Morrissey. Kira is starting a job at Boeing as a loads and dynamics engineer. She would like to thank her friends, family, and the faculty for their support during her undergraduate career. Isabella Neville. Isabella would like to thank everyone in this department that has helped her over the last few years. It was a great time, and she is now ready to take all these skills into the workforce. Dennis No. Dennis is proud of the work he and his fellow team members did on the Husky Satellite Lab Lunar Ground Penetrating Radar capstone. Tu Viet No. Tu is proud of his contributions to the Boeing-sponsored small single-aisle airplane capstone project and his leadership in Husky Satellite Lab as a structural engineer lead. This fall, he's excited to continue growing his structural engineering skills in the UW MSAA graduate program while pursuing opportunities in the engineering field. Philemon Wynn. Philemon would like to thank his parents and sister for all their support over his time at UW. Tim Nguyen. Tim would like to thank his parents for supporting him through thick and thin over the course of his academic career. Megan O'Neill. Megan is proud of the work she did in the nonlinear dynamics and controlled lab, as well as her 4-year participation in the Husky Marching Band. Megan is excited to start her job at Boeing as a flight test instrumentation engineer. Adam Olson. Adam would like to thank his family and friends for their constant support, encouragement, and belief in him throughout his college journey. Yabet Sonkiso. Yabetz would like to thank his parents, friends, and above all, God for helping him persevere through his college journey and for encouraging him to always have faith. Alexander Jakob Sunghyung Peck. Xander would like to thank his family for their support and is proud of the work he did on the Radian 1 capstone project. Clara Park. Clara is starting a job at Boeing as a stability and control engineer. Clara would like to thank her family and friends for their love and support. Edward G. Sun Park. Edward Park will be heading to Randolph Air Force Base for pilot training as a remotely piloted aircraft pilot. He is grateful for the unwavering support of his family, friends, and girlfriend. Alexei Polyakov. Alexei would like to thank his wife, Carla, for supporting him and never letting him give up. Gennady Rethnyaka. Gennady would like to thank her parents and sister for their endless support and encouragement. Prabhav Arawat. Prabhav would like to thank his family and friends and will be starting a job at Blue Origin as a manufacturing engineer. Drew Rivers. Drew Rivers is starting a job at the NASA's Johnson Space Center in Houston, Texas as a propulsion flight controller in the Flight Operations Directorate branch. Drew would like to thank her 3 kids, mom, partner, and family for their shared sacrifices and support. Joshua Rolfe. Joshua would like to thank Jesus Christ for always being by his side, providing, protecting, and counseling him. Marcial Romero Gomez. Marcial is excited to be continuing their education at the University of Washington next year, obtaining an MSA Fluids Focus. Audrey Ann Rasso. Audrey would like to thank her parents and WSDOT. She's excited to start work at Boeing in Everett as a structural analyst. Yulia Rosas. Yulia is starting a job at Boeing as a flight test engineer. She would like to thank her family and friends for their unconditional love and support. Henry Rothschild. Henry would like to thank his family and friends for their support and is proud to have been part of 3 top 10 finishes at UW Formula Motorsports, an incredible capstone group. Raul Ruben Sanchez Lopez. Raul would like to thank the GD capstone team for a great quarter last year, and all the administration support staff that kept the AA program running behind the scenes. Alejandro Santana. Alejandro is starting a job at SpaceX as a manufacturing engineer. He would like to thank his family, friends, and everyone at DBF for an amazing 4 years. Nia Sarapella. Nia would like to thank her family for their unconditional support, with a special shout out to her sister Natiga for being her biggest cheerleader. Dylan Schultz. Dylan will be working at Aerojet Rocketdyne as a manufacturing engineer after graduation, and he couldn't have done it without the support of his brothers at 4547 and SIG Ep, as well as his family and classmates. Teddy Seligman. Teddy hopes to one day play trumpet in the test section of the Kirsten Wind Tunnel. Nirav Shankar. Nirav is proud of the work he did as a part of the Aerodynamics sub-team on Design, Build, Fly. He is excited to continue his education next year with a master's in aerospace engineering at Georgia Tech. Anson Seidel. Anson would like to thank his family for their continued support and his friends for a memorable 4 years. Sebastian Sosa. Sebastian is thankful for the everlasting support from his family, the lifelong cohort friends he found, and the community he made in UW Rugby. Yash Srivastava. Yash is deeply grateful to everyone who supported him on his journey to earning his degree in aeronautics and astronautics. He's proud to begin his next chapter by pursuing a master's in aerospace at Georgia Tech. Dylan Steckline. Dylan would like to thank his parents for always supporting him and being there through all the highs and lows he's had over the past few years. McKenna Miyako Tsukimoto. McKenna would like to thank her parents, Tim and Maria, for their unconditional support and of her dreams and aspirations. Hugh Srecker. Hugh was an active participant within the AA community, serving as president of Husky Flying Club and as a research assistant in both the quantitative flow visualization and RAM accelerator laboratories. Harry Trung. Harry would like to thank his friends and family for supporting him through these last 4 years. Luke Van Sickle. Luke Van Sickle will be serving in the U.S. Air Force as a pilot. He would like to thank his family for supporting him and making this possible. Stella Van House. Stella is starting an internship this summer at General Dynamics as a guidance, navigation, and control engineer. Kat Watson. Kat is enthusiastic to be continuing their education as a graduate student in the AA department at the University of Washington next year. Elisha Webb. Elisha is continuing on into graduate school, pursuing a Master's of Science in Technology Innovation, Robotics track here at UW, Redmond, Washington. Dante Gary Da Silva Wurasuria. Dante looks forward to pursuing a Master of Science in Aeronautics and Astronautics at the University of Washington this fall, and is proud to return this summer for a third internship with Boeing's Loads and Dynamics team. Kean West. Kean would like to thank his wife, Ruby, for her support during these past 4 years. Antonio Yang. Antonio Yang is proud of the work he did on the General Dynamics Capstone project and would like to give special thanks to the entire General Dynamics Capstone team, but especially the payload function team, Dr. Dabiri of the hypersonic wind tunnel, and the systems engineering team behind the stability testing device rocket that crashed at 50 Acres Park. Andrew Uhima. Andrew Uhima is proud of the work they did on Formula Motorsports and would like to thank his friends and family for all the support. Yannick Zender. Yannick would like to thank his family and friends for supporting his passion in aviation and is excited to start his aerospace career this summer. Anthony Zhang. Anthony would like to thank his friends and family for their support in his undergraduate studies and is excited to be continuing his education in the University of Washington's MSAA program in the fall. Jeffrey Zhang. Jeffrey, who is returning to Boeing in Everett as a reliability and maintainability engineer while pursuing an MS in aerospace sustainability at Embry-Riddle, hopes to make the skies of the future cleaner for generations to come. He extends his heartfelt thanks to Professors Dabiri, Habtoor, and Mesbahi for the guidance in aviation research.
Okay, before we start the phase 2 of the program, no, I'm kidding. And I wanted to thank everybody, including the staff, who basically put all this together and make it so seamless. Thank you, Professor Harlan, and congratulations to all of you, our exceptional graduates this year. As we conclude today's celebration, I want to acknowledge everyone who made this moment possible. Thank you for our dedicated staff and student volunteers who ensured today ran seamlessly. Thank you to our faculty whose commitment to excellence in teaching and mentoring has shaped these outstanding graduates. Thank you to the families and friends who joined us today. Your unwavering support and encouragement throughout this journey has been essential to our students' success. And thank you to our class of 2026. It's been our honor to guide you and your learning and witness your growth both in classroom and beyond. As you embark on your aerospace career, you carry with you just not technical expertise, but the problem-solving skills and innovative thinking that will drive our industry forward. You're prepared to tackle the challenges ahead and to push the boundaries of what's possible in air and space. Go forward with confidence. The aerospace community eagerly awaits your contributions. And now, graduates, please stand. 1 minute. You may now move your tassels from right to left. It is my honor to present the William E. Boeing Department of Aeronautics and Astronautics class of 2026. We applaud you all. We ask all guests to remain seated for the faculty students to recessional. Graduates, you're now clear to take off.